Okay. Couple of homework questions I want to go over. Okay. Couple of homework questions I want to go over because, one, they were highly missed. So, first one, I understand this one. This one is one that's going to come up in 8.3. But let me preface it and make sure you guys understand why you may have missed it or what we got talking about. They want me to interpret the confidence interval. So when we interpret the confidence interval, we start off with we are 95% confident that the true mean or the true proportion in 8.2 and 8.3 in your test is going to be proportion, not means. So we are 95% confident that the interval from here to here captures the true difference. That one looks like it's starting off pretty good. Okay? The true difference, boys and girls, mean number. Girls at this school have been between, it's not that. That's not interpreting it. Okay, that might be what it means, but that's not interpreting it. We are 95% confident the interval from here to here captures the true. So this one's careful. This one starts off the same way, but this one says the difference in mean. And then this one was the true difference in the mean. So this one is not leading to the population. Okay, and then also basically says sample at the end. So samples always knock those things out for being wrong. We are 95% confident the interval from here to here captures the true mean difference in the number. Ooh, so there's these two are different slightly, very slightly, and again, that's what you're going to have to notice, and it's really the difference between 8.1 and 8.2. Well, I shouldn't say that. It's the difference between it's 8.2. 8.3. Sorry. 8.3 is where you're going to learn this. Okay? So the true difference in the mean, and then this one says the mean difference. The mean, you know, is the average. And so that's the average differences. That's not what we did. We didn't do the average differences. We did the difference of the averages. Kind of follow that? Again, hopefully if you missed this, and I can go back and look, but hopefully if you missed it, it's because you chose this one instead of this one, because those are the only two that would come close to being correct. Okay? Do note that I can kind of see how many attempts it took for you. And when I see 2, 3, 3, 3, 3, 2, 3, and how much time you spent on the homework, that tells me you're not working really hard. Fair enough. I get a lot of reports on this kind of stuff now. So if I see 3, 3, 3, 3, 3, my hair is jacked up. I gotta get a haircut tomorrow. That just tells me that we're just clicking. You're not learning anything from your homework, right? So what can I do to do better on the test? It pretty much answered your own question, right? Okay. Next one I want to go over. Battling cola. Particular type of cola advertises at 12 ounces of this one. You got to understand this. You got to understand this. Advertises at 12 ounces in beverage. Each hour, a supervisor collects 10 cans at random and measures the content, computes a 95% confidence interval, and found a 95% confidence interval between 11.97 and 12.05. 12's in there. 12's in there, so I can't dispute that claim. If 12 was not in there, you can dispute that claim. You can dispute that 12 is not the average, but 12 is in there. And so the very first one, because 12 is one of the plausible values in the 95% confidence interval, there is not convincing evidence that the true mean volume is different from the 12 ounces, and that is the answer. Because 12 is in there, you cannot dispute it. It has to be a plausible value. And not only is it plausible, it's very plausible. Because 95% confidence interval contains values other than 12. I don't care about that. All I care about is the 12. So I can stop reading right then. Even though this confidence interval includes 12, this might not occur again in a different samples. There's not enough. We're only doing this one time. We don't mess up. We don't mess up. We are 95% confident the interval from here to here contains that. Well, that's great. That doesn't tell me if it's true or false. That's just interpreting it. We are 95%, again, that's just interpreting it, and one of those is wrong, I'm sure. Oh, 12 is not in the center. I don't care if 12 is in the center or not. 12 is the average. That would be, if it's in the center, that's P hat, or in this particular case, X bar. Okay? Again, good. Some of these are really, really good questions that I really think that you can learn from this. A lot missed this one, and maybe I see why, I don't know, but the figure below shows the resulting of taking 25 SRSs. We know we're only going to take one, but if I did this over and over and over again, so now they're starting to talk to me about interpreting the level, right? From a normal population and constructed the confidence interval. So I know that I have 25 of those, and out of those 25, I missed it 1, 2, 3, 4 times. I missed it 4 times out of that 25. So I must have hit it 21 out of that 25. So I hit it 21 out of 25. Oh, I did that earlier. 21 out, that's 84%. So I should have done something close to an 84% confidence interval. Does that mean that I'm always going to hit 84? No, that's in the long run. And so I look at my choices here, and I don't have 84. But the closest thing to 84 is 80. The closest thing to 84 is 80. I wish they would have put 84 or 85 or something closer to it, but they didn't. So I got to choose 80. Okay with that? I think there was one more that I wanted to go over. Oh, explaining confidence. This one, I get why you missed this one. Hopefully you learned something from this one, but I get why you would have missed it. Okay? A 95% confidence interval from the mean body mass index is 26.8 to 0.06 or 0.6. You'll see it this way a lot of times. They won't actually give you the interval. They'll give you the point estimate plus or minus that margin of error. That's the way they'll give it to you a lot of times. But you know that if you add 0.0 or 0.6 and subtract 0.6, you're going to get that 26.2 and that 27.4. So one of your classmates interprets the interval by following any value from 26.2 to 27.4 is believable. And that's actually a true statement. That's not interpreting the interval, but that's a true statement. And that's not what it says. One of your classmates interpret, I guess they do say interpret this intervals. Incorrect, you can only use, so that's, incorrect, you can only use the sentence. I told you, I understand, like I said, I get this because I ingrained that in your head, right? But that's not incorrect what he said. That's what we would be very surprised if it was not in that interval. We won't be surprised if it's in that interval. I don't know if that would hit the rubric or not. Fair enough. So again, I can see why you did what you did. I just want to kind of understand it or explain to you at least, even though he didn't probably say it 1000% correct, I don't think it's not incorrect. Okay? I think that was the last one I wanted to go over. Oh, I get that. I didn't do anything on the bias on the test, but yeah, I think it was the next one. Not explaining prayer in school. Yeah, that was one of them. Yeah, that was one. Again, bias is tough to me. Select all practical difficulties that may cause from this, and I think it was non-response and response. Is that what it was, or undercoverage, or on the AP test? Of course, you'll never select more than one. I don't think they'll put bias. If it's bias on as a multiple choice, it's going to be obvious which one it is. Obvious, because it can only be one answer, right? And if it's free response, as long as you don't lie and put a wrong one, fair enough? So if it fits any one of those other ones, you're okay with it. And so again, no, I didn't put anything on bias on it. I did not, because I'm focusing on confidence intervals. Good question. What else about confidence intervals? Anything about it? Anything about them so far? Hopefully you understand why we're doing them, right? AP threw in a trick question one time, and I think it's one of my questions. I don't know if it's chapter 8 or chapter 10 or chapter 12, or I don't know where it is, but at some point I say, we know that the population average is something. And then we go ahead and construct a confidence interval. And somewhere on there should be something of why are you constructing a confidence interval if you know what the population average is? Fair enough? Because if we know what the population average is, there's no reason to do a confidence interval, because that's why we're doing a confidence interval. We don't know what the population average is. Okay with that? I forget where that question is, but I just know it was thrown in at some point in time. So just understand, why are we doing these things? Because we don't know what the population average is. We don't know what it is. Okay, everybody happy, happy, joy, joy. Here we go today. Let's show you how to make these stupid things. Let's show you how to make these things. So, chapter 8, 8.1, introducing them. 8.2, we're going to make them. 8.3, we're going to make them. 8.1 is going to deal with one sample. One sample. 8.2 is going to be two samples, and we're just basically talking about the difference, kind of like that shoe question. The difference between girls' shoes and or the number of girls' shoes and the number of boys' shoes. I don't care how many girls have, and I don't care how many boys have. I care about the difference. Okay, that's 8.3. There is no introduction in chapter 10. We only go 10.1 and 10.2, which is one sample means and two sample means. Fair enough? So again, I cannot emphasize how important getting this down is, because when I hit this in chapter 10, it's almost identical, except using p-hats, we're going to use x-bars. And the standard deviation's a little bit different, but you guys learned that already with sampling distributions. Again, just trying to preface where we're at and how important it is that you get it now, because I'm telling you, when I hit chapter 10, I'm going pretty darn fast, because I don't want to spend a whole lot of time talking about it, because there's not a whole lot of difference. Button, yippee yippee yo, click, confidence intervals, plausible values of an estimate of some unknown population parameter, right? Again, it's unknown population parameter. We know what that is. Okay, I'm going to jump right into the formula. This formula is written on your formula sheet exactly like it is. I'm getting ready to show you. We're used to seeing formula as variables. They're going to give you this formula as words, because it's the same formula for chapter 8 and chapter 10. You have to turn it into variables. Okay with that? First word is statistic. I mean, we've been in this class long enough now. You know a statistic comes from the sample. And so that statistic is going to be one of two things. It's going to be X bar or it's going to be P hat. You got a confused look on your face, Paige. What do you got? I don't have my weight sign anymore. I get it. Okay. Whole part whole. I'm giving you another whole. We'll break it down to parts and we'll go back to the whole. Okay? Statistic. Okay? Again, this chapter, it's going to be P hat because everything's categorical data. Everything's categorical data, so that statistic is going to be, in chapter 10, that's going to be X bar. Okay with that? Then they're going to put the plus or minus. We also called that statistic, what did we call that thing yesterday or 2 days ago? The point estimator. Right? That's what we're starting with, that statistic, that point estimator. That's going to be the same thing there. It's coming up in a second. Critical value. Now, the critical value is different in chapter 8 and chapter 10. But again, you don't care about chapter 10 right now. All we care about is chapter 8. And then the standard error of the statistic. The standard error of the statistic, which is basically the standard deviation of the statistic, but they changed that standard deviation into standard error. We'll talk about that in a couple of slides. But this is the formula that's written on your formula sheet. It's going to be your job to turn this into variables. And it's not that difficult, especially as many as we're going to do in class. Okay? And like I said, you already know one of it. You already know the statistics. So I just got to go with critical value and standard error. And you actually know this and that already. We just got to get it there. Okay, everybody good? Pencils? Click. All right, here we go. Statistic comes from the sample. and it is that point estimate, okay? It's either going to, I'll just go ahead and tell you, for categorical data, proportions, this chapter, that's going to be p hat. It's going to be p hat. Say again? Point estimate. That is correct. The point estimate, what I'm going to start with, what are they giving me with? That's that middle value in my interval, right? That's that middle value in the interval, because then I'm going to add all this and I'm going to subtract all of this. And all of this is what we call, we don't know that already, that is the margin of error, right? We kind of already know that too. We'll sum all this stuff up again. I'm doing a whole part whole. I'm throwing little parts in with it, but okay? Everybody okay with the statistic part of it? So on your paper, I'm not going to write statistic. I'm just going to write p hat, because every grader knows that if you write p hat, you're talking about the statistic. And so we understand that you understand that that's what we're talking about. Now, for numerical, this will be X bar, that's chapter 10, chapter 10. Okay, critical value. Critical value. It's the z-score. It's the z-score that's associated with that level. That's what the critical value is. Now, we're going to talk about the critical value quite a bit this semester. And so that word is really, really going to be important to you. The critical value. It's critical. But in this particular formula, that critical value is the z-score. The z-score. And it's coming from the level. It's coming from the level. So again, that's why we do that 95 a lot, because if it's 95, what's the z-score associated with 95? 2. If it's 99, the critical value is 3. And if it's 96 or 97, then we got to find it with a table or a calculator. And I'll show you all that stuff just to make sure. Okay? So that's the z-score that's associated with that level. That's how many standard deviations out I'm going. The z-score that's associated with that level. Okay? That will typically be given in the problem. It will typically be given in the problem. And if it's not, just use 95. If it's not, just use 95. And if you really want to use 90, use 90. They don't care. If they don't give it to you, you're just going to tell them what you're going to use. I mean, no, I don't. There might be one question you have to do that with. I don't know. Don't remember. Okay, everybody good with the critical value? Critical value. Now, the standard error of the statistic, you actually know this already too, okay? It's that part of it. Square root, p hat, 1 minus p hat over n. P hat, 1 minus p hat over n, square root. I think you have seen something very similar to this previously. Yes? Chapter 7 with sampling distributions. The difference between chapter 7 and this chapter is this has hats. Why does this have hats? And in chapter 7, we didn't have hats. Because we didn't know what we don't know what the population is, right? If we knew what the population is, we don't have to do these things. So if I don't know what it is, if I know what it is, I'm sorry, I said that backwards, I guess. If I know what it is, there's no reason to do a confidence interval. So that's why this has to be a p hat. And that's why they call it the standard error as opposed to the standard deviation. It's not the standard deviation of the population, because I don't know what the standard deviation of the population is. They're going to call it the standard error because that's the standard deviation of the sampling distribution. Okay with that? Okay. Why are we using p hat instead of p? That's important because we don't know what p is. If we knew what p is, then we don't even need to do a confidence interval, right? So that's why those have to be p hats. Over n, again, you already know that part. It's already over n. Let me show you. I want to make sure that you do see this on the formula sheet so you know where it's at. Formula sheet, page, complete one, formula sheet complete. Uh-oh. Come on. Come on. Maybe it's coming. Yep, here it is. I'll try to zoom it in a little bit just to make sure. Again, by the end of this, you won't use it because you're going to have it. So you're going to do it so many times. Confidence interval, ... Statistic, plus or minus critical value, standard error statistic. Okay? You got to know statistics, either going to be p hat or x bar. In this chapter, you have no choice. It's going to be p hat. I'm not going to give you an x bar. The critical value will only be z, because that's all we're doing in this chapter is categorical data. And the standard error, the statistic, oh my gosh, I don't know what that is. Oh, guess what? Whoops, I went too far, or I didn't go far enough. This is page 1, sorry. Page 2, standard error of the sample statistic. Right there. Because we are dealing with one population. Actually, we're dealing with one sample because we don't have one population. Guess what? Tomorrow, or next class, 2, it's going to look like this one, which looks like this one, except this one has hats. So you, like I said, you kind of know all this stuff. We just have to make sure we tie it all together and not necessarily make sure you know this, but you really know the difference and why it's different, right? That's a big thing about AP. It's not necessarily how, but the whys. So, statistic, critical value, standard error, statistics written on your formula sheet. You're going to have to turn statistic into a variable. Pretty easy, I think. P hat or X bar, and it's only going to be P hat now. Critical value, you got to know that Z. You got to know that Z. Chapter 10, it won't be Z, but right now you got to know it's Z, so that's all we'll stick with. Standard error, the statistic, you should know that it's this. But if you don't know it's this, that's on the formula sheet too. You just got to know how to manipulate that formula sheet to get to that value. And again, by the end of this, you won't look at the formula sheet that much because you're going to do this so many times, you're going to know what it is. Happy, happy, joy, joy. Any pencils? Any questions? You got the formula? We're done. Okay, so here let's talk about the standard error, just to make sure you understand the difference between standard deviation and standard error. Because when you see standard error, that starts confusing students because they're going, I don't know what the standard error is. I know what the standard deviation is. And they are the same type thing. The standard error is when the standard deviation of statistic is used, not the standard deviation of the population. So when I'm using statistics, when I have, oh, I forgot to start my little pencil. I'm kind of happy about this. I had to pay for it last year to have this pencil. It ran out, but it's still letting me do everything. So it's kind of cool. Because I have P hat and 1 minus P hat, it is now standard error. As soon as you have P hats, it's standard error because I'm using P hat to estimate that population. Again, all this is radicaled, okay? So just be cognizant of that word, standard error. When you see standard error, that has to mean we're just using sample stuff. We're using sample stuff as opposed to standard deviation. Other than that, they mean the same thing. This is just telling me it's the standard deviation of the sample as opposed to the standard deviation of the population. Here we go already. I told you guys this already. I think some of you guys have done this, but the standard statistic will be P hat. The critical value will be Z. The book, the test, worksheets, questions, we'll put a star. That's not times. It's Z asterisk. I don't care if you put it or not. A lot of times I don't put it. If you do put it, but that's not times. That's a Z star. It's an asterisk. because we're estimating what it is. Just go with it. And you don't have to. You don't have to. If you just put Z, it's okay. They don't care. I didn't put Z star for the longest time. Or the first 3 books I used didn't use Z star. This book does, and it confuses students, so I'll put it back in there. Because what's this star thing? It just means we're estimating the Z from it, okay? And then that's P hat 1 minus P hat over N. So you don't have to write it in words. I wouldn't write it in words because I think that would take a lot longer. You can write it with variables just as easy. You've got to define these variables. And what's nice is all I need is a P and a Z and an N. P hat, P hat, P hat, Z, N. Okay? And you already really know the Z because most of them are 95. And if most of them are 95, that Z's 2. We're going to get a little bit more accurate than 2 in just a second. Okay, pencils are still going. Let them go. I don't want to go too fast on this. I told you guys. Now, ironically, chapter 10, this is going to be X bar. This is going to be different. And then this is going to be different, but you already know it. It's just going to be S over the square root of N. You're used to seeing sigma over the square root of N. But we don't know the population stuff. We have to use sample stuff. Again, chapter 10. I hate this board. Okay? Click. All right, so let's talk about how to get that Z, because I think everything else you already know how to get. You already know how to get P hat. You already know how to get N. Z is the only thing we don't know, and we kind of know that. We just I gotta make sure you know how to get that. Okay? I don't want there to be any confusion on how we're getting that Z star score. So, finding the critical value for a 95%. Confidence interval starts by labeling. You don't have to do all this stuff. I'm just trying to put this picture in your head. The middle 95% under a standard normal curve. So here, again, we know what a standard normal curve is. Standard normal means 0, 1. Okay, standard normal curve means Z-scores. That's the mean. And if I want 95%, that's that right there. And we learned by the empirical rule that should be a 2 here and a -2 here. Good enough? And if it's anything else, then you're going to probably use your calculator or you're going to use your table. If I have the percent and I'm going to Z, that's not normal CDF. Normal CDF goes from Z to a percent. So we got to do that inverse norm. And luckily, you guys have somewhat of a decent calculator. Most of you, I don't think there's any 83s running around here anymore that will do that left, right, middle, right? Because we want that middle. We want that middle, okay? So here's that nice picture. Here's that 0.25. There's the positive Z. There's the negative Z. There's a standard normal curve. There's the area of 0.95. There's an area here of 0.025. That's important to know. You already know that, but it's important. If this is 95, there's 5% left over. And if there's 5% left over, there has to be half a 5 on this side and half a 5 on this side. If it's 90, there's 10 left over. And if there's 10 left over, that puts 5 on this side and 5 on this side. You need to know that stuff. Okay? All right. Now, here's where we're going to just do a slightly bit different. Okay? You know it should be 2 and -2, but we want to be more precise than that. 2 is an estimator. 2 is estimated. So if you do inverse norm of 0.95 with that middle, you're going to get 1.96 and -1.96. And you'll have this memorized after doing it for so long because it's the same score every single time. Okay? So let me show you on your calculators really quickly just to make sure you guys know. On your calculators, right? We're going to distributions. We're going to distributions. I don't want normal CDF because that first one's PDF, right? Don't use PDF or anything. We don't use PDF or anything. It doesn't tell me anything. Normal CDF takes the Z-score to the percent. I don't want that. I need the percent to the Z-score. And so that's the inverse norm. That's the inverse norm. I have a left, right, center. If you don't have left, right, center, you're going to have a little bit more work to do. because you only have left. And if you only have left and you put in 95, you're going to miss it. Again, stuff that you should easily understand, but I want to make sure you do, right? I want the middle 95, right? If I don't have center button and I do 95, you're cutting it short because it's only going to the left and you're cutting it short. So make sure if you don't have a left, right, center that you compensate for that. Yes, sir.
Why do we have to do all this? We're using 95 instead of 1.60.
Because on the test, guess what? They're going to change it to 98 or 94. Fair? Because they want to make sure you know how to find it. Y'all hear what his question was, right? Why do I have to do all this stuff if it's always going to be 90? It's not always going to be 95, right? If it's 90, do you know what the z-score is for 90? 1.645. Well, you will too by the end of this chapter because you'll do it enough. But, yep. You can. I'll have to pull it back up to show. I know we can. I know we can. Calc. Yeah. But I'm just not comfortable with Desmos yet. Click. Any question about that z-score, finding it? Oh, I thought I did. I didn't finish it, did I? Sorry. Thank you. Good question. Sorry. I got all fired up and had a question. At 0.95. Okay, 0.95. If you don't have this stuff, right? If you have a CE and you don't have left, right, center, I can update your calculator to get left, right, center. CEs are the only ones that do left, right, centers. Old 84s don't and old 83s don't. But 0, 1, because we want the z-score, right? And I'm just going to do center. Do center. And then I just paste it, and that gives me that negative 1.96 and that positive 1.96. Typically, we report the positive one. It doesn't matter. They won't care if you report because it's z plus or it's a p hat plus or minus, right? Y'all, we had our own conversation up here, right? Well, I have both. I have a negative and a positive, but your formula has that. It has p hat plus or minus, right? It's because it's plus or minus that z-score. Correct, because it's the distance away. That is correct. Okay. Again, 90% is common. 90% is common. So if we want 90, it's center, 0, 1, paste it, and there's the 1.645.
And so they don't give percent, you just say use point.
I don't know that one. I know 99, and I know 90, and I know 95.
No, yeah. No, yeah. Oh, it's getting even more precise than just 960. Is that what it's doing?
Yeah, because as my confidence level decreases,
Yeah,
my interval decreases. Oh, we just round it. It's a decimal, yeah. Okay.
I understand that.
Okay. Okay. All right, any questions about that z-score? All right. If you have to, you can use a table. If you have to, you can use a table. Let me just show you guys on the table just to make sure in case your calculator dies or something, right? On the table, you got to go to Z scores and find that. Whoop, I'm sorry, I'm on the wrong one. I'm on the T's. You got to find 90% inside of here. You can't find 90% inside of here, or 95, I'm sorry. Don't find 95 in here because that's going to cut it short again. Remember, this includes the tail. I'm trying to sum all this stuff up. If you put 95, it's going to shorten it up because you've included that tail. I want the middle 95, and this includes the tail. So if it includes the tail, you got to add that 0.025. So I actually have to look up 0.975 in here. No. But if your calculator dies, you got no choice. Okay? Oh, yeah. Yeah, that's all we had. Okay, good. Pencils, any questions? Any other questions? You guys are asking great questions. Okay, clicky, click, click. 90%, I just showed you guys how to do 90%. You'll have 90% memorized because you'll do it almost as much as 95, but it'd be 1.645. Remember, the tail area is 0.05. It's important to know the tail areas, but you should know that already from chapter 2. Okay? Yep. Oh, 99, 2.576. Y'all remember now, when we did 99 in the empirical rule, we said that that's 3 standard deviations, but it's not really 3 standard deviations. We said was 99.7, right? And so that's why this is not really even close to 3, although it is close to 3. But that's why when we say 99, we don't want to go all the way out to 3. We want to use 2.576. We want to be as accurate as we can. And yes, 2.576 is a whole lot different than 3. When we're trying to talk about an interval and we're getting it as close as we can, 2 or 3 decimal places with percentages is quite a bit. Yes, ma'am. They don't care. I typically do 3 or 4 or 2 or. Good enough of that too? Everybody else okay? Click. Those are the 3 most commons. Those are the 3 most common. On the test, I'm probably going to throw you a little curveball and tell you 96, or I want to tell you 93 or something like that. But then there'll be some on there also that will just deal with these. But I want to make sure you know how to find it. I know for a fact one of your multiple choices will be what is the z-score for, or I don't even say that, I say what is the critical value for this percent. And it's one of your multiple choices. Say again? I mean, hopefully you would know that, but no. Next Friday. No, you guys got it Tuesday. You got Tuesday. Not Tuesday, the next Tuesday. Yep. I'll show you in just a second. I'll show you what the distribution was last year. You can decide. There were 8 100s. Okay, psst, focus. Got to finish. We're not done. Okay. So here, big picture, confidence interval. You're going to be asked to do a confidence interval on the test. You're going to be asked to do a confidence interval on the test. One of the E's, P's, or I's is going to be interpretation. One of the E, P's, or I's is going to be an interpretation. Another E, P, or I is going to be the actual interval. Okay? Here's the other interpretation, or here's the other one, right? There's 3 parts to that formula. There's 3 parts to that formula. The first part, the statistic, the critical value, and the standard error of the statistic. 3 parts. So because there's 3 parts, we have to have 3 conditions to make sure all 3 parts are legal to use. Okay? There are 3 parts to the formula. In order to validate the use of those in that formula, we have 3 conditions that must be met. 1 for each part. If any one of those conditions is valid or invalid, then I can't officially use that part of that formula. Okay? So here we are, 3 parts, 1, 2, and 3. And again, we talked about it, p hat, the critical value, and the standard error. And so in order to validate this p hat right here, guys, seriously, in order to validate that first p hat, it must be a random sample. It must be representative of that population. It must be good enough to draw conclusions to the entire population. It's kind of where I was at too. If y'all want to chit chat, go. I don't care. Just slide out. Okay, it must be valid. So in order to validate that p hat, you guys learned this in chapter 4, right? I cannot draw conclusions to the entire populations if it's not a representative sample of the population. And so that's what they're going to want to make sure. Make sure we have a simple random sample. Make sure we have a good representation of all, whatever it might be. Most of the time, they're going to tell you in the problem. If this one's not met, guys, it will be obvious. It will be obvious if it's not met. And the way it's not going to be met is they're going to say it in the question, like, are the conditions met? This is a very common question on AP. Are the conditions met? Yes or no? They either are or they aren't, right? And the most time when they ask you if they are, they're not. One of them is invalid. And then the very part after that is using advanced statistical software, we found the confidence interval to be this. Interpret this confidence interval. And so you just interpret it. Fair enough? Okay, so in order to use this, it's got to be a good representation. It's got to be a good representation. What do we know about the z-score? In order to use a z-score, it better be what type of shape? Normal, right? How do we know if something's going to be normal or not? Large counts. We got to have large counts. We got to have large counts. Y'all remember how to do large counts with proportions? Because I know all this stuff kind of soaked in together at one point. Large counts for proportions is different than large counts for means. That's not that part of it. A lot of you guys missed this on the test, so I want to make sure we want to get there. The large counts for proportions, you got to have 2 things. N times P, except I won't have N times P now. It's going to be N times P hat. And that better be what? Bigger than 10. And N times 1 minus P hat better be bigger than 10. That tells me that the large counts condition is met. I have a large enough sample size to validate that I have an approximate normal distribution and I can use a z-score for it. If the large counts condition is not met, I can't use a z because we know z's are only associated with normality. Yes, ma'am. Yeah, it's fine. It'd be fine. Officially, it is equal. I don't ever do it because I don't think I've ever seen it exactly 10. And if you don't put the equal sign on the test, they won't care. I mean, everybody okay with the large counts condition? Gotta have it. Gotta have it. And guess what you're going to have to do? Not only check it, show that you checked it. Because if you don't show these conditions, you're getting dinged because this is its own EP or I. This is its own EP or I. And then this part right here, how do I know I can use the standard error? 10%. What's 10%? Our sample better be less than 10% of the population. That's the one that I put -1 on. Let's say there's 110 of you guys that took it. I bet I put it on 108 of them. Because you cannot use this formula if you don't tell me this. You can't. This formula is invalid if this is not true. And so the only way to use that formula is to say that this is true. And what if this is not true? Then this doesn't work. You don't take this class. You go to college. Take a different one. And it's one after this class. Most of the time, your population is really, really high, though, right? I mean, it's going to be hard to be not less than 10% of all. It's going to be hard to be not less than 10% of all. 10% condition. Guys, I can't tell you that they must be checked. And on this test, that is probably the most minuses I'll put, is by not checking the conditions. Because you know that they're going to be met. Because if they're not met, we can't do any of this. So they're going to be met, but you got to validate that they are met. You got to validate it. You can't use that part of the formula. Fair enough? Again, let's emphasize this. You guys are asking great questions. Awesome. If the first part's not met, we don't have a random sampler, it's not representative of the population. What does that mean when I get my confidence interval? I really can't judge that to all. Fair enough? So if it's not met, then that's the punishment, that's the consequence of not. If it's not normal, I really don't know if that's the z-score for it. So our interval is not valid. And if our interval is not valid, then it's probably not part of the population. Although we still understand that all that stuff is a little wishy-washy because that's all we're going off of anyway is samples. Kind of okay with all that stuff? And then the 10%, that formula doesn't work, but the formula that they do use is close to that formula. It's just a little different. Don't worry about it because it'll always be met. But you got to check them. It's its own EP or I. On my test, that's 4 points. 4 points. You don't check them, that's -4. Right? So you got conditions that's worth 4 points. You got a conclusion that's worth 4 points. That's 8 points. You're probably going to have to interpret the level. There's another 8 points. Or 4 points. 4 times 4. We're at 12 points. The free response is only 26 points. Got you pretty close. Fair enough? Yes. Could be, yes. Yep. And you'll see some on your homework tonight. Yep. You'll see which of the following conditions has not been met. Or they've all been met. Fair enough? Okay. I'm telling you, this is a question on your test. You will have to construct a confidence interval. And it will say construct and interpret. Construct and interpret. And so when you see that, this is like a 12-point question. It's a 12-point question to construct and interpret. And I'm telling you that that's going to be a question on your test. Okay? Construct and interpret. It will more than likely be a question on the AP exam. Construct and interpret. And they'll have a little box right here and they'll give you a whole page to write on it. Just a blank page for you to fill it all in because you got a lot of work to do on this. Because we got to check the conditions, we got to show the work, and we got to write a conclusion. Fair enough with all that stuff, good? And so they're going to call it a 4-step process. I call it a 3-step process, but the book calls it 4-step. The book calls it a 4-step. AP doesn't care how many steps it takes you, you just got to get it all in there. Fair enough with what I'm saying, y'all okay? You got to get on there. So the conditions are one of them. You got to check those conditions. That's kind of one of the steps that they'll talk about. The work or the calculations, and I'm going to put all this up here in a second. And then you got to have some type of a conclusion. Okay? And some of you might put more than others, and some of you might put less than others, and both of you might still get full marks. But somebody might leave something out, and you're going to get bad marks. And so what if I only do it in 3 steps? Okay, good. I don't care how many steps. I only do it in 1 step. I just get it all done. Okay? but just kind of, this book says 4-step process, so I just kind of want you to, you might see that on homework. Y'all know that formula, E equals MC cubed? Isn't that a formula for something? Mass or? Oh, it is. We want E's on tests, right? Ha, 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 ha. MC cubed. Those are my 4 steps. M, C, C, C. Those are my 4 steps. M, C, C, C. So let me give you each one of those. M is going to be the method. M is going to be the method. What are we doing? What are we doing? You are lucky in the fact of right now, you only know one method. This is the only method you know. This is it. On Tuesday of next week, we'll pick up the next method. We'll have another method in chapter 9. We'll have 2 methods in chapter 9. We'll have 2 methods in chapter 10. We'll have 2. So the methods grow, but right now you only have one method. On the test, you'll have 2. And it's going to be, if you miss it, then you're in the wrong class because you don't know how to count 1 or 2. I'll do it in a second. Your method is 1 sample. Anybody have an idea of what Tuesday's method is going to be? 2 sample proportion. Why is it proportion? Because we have categorical data. Why is it Z? Because Z's go with proportions. And why is it interval? Because that's what we're finding. You are telling the grader, this is what I'm going to do. I'm going to do a 1 sample proportion Z interval. Let me give you the rubric. The rubric always says, student names the process by name or formula. By name or formula. That means you don't have to do both, but you better do one of them. What if I do both? Yay. Okay? I do both because I'm scared I'm going to forget one of them. But if you got method and you got this down, you don't even have to write the formula. You don't have to write the formula. But either this or the formula better be on your paper. Okay with that? So 1 samp, and you can abbreviate. 1 samp prop Z int. I don't care. AP won't care. Everybody in the world that understands a little bit about statistics know what you're talking about. Okay? So if you would rather write this or write the formula or write both, you're good, right? If you write this and the formula and you end up with one of those 0.5s, that gives you more ammunition. This cat really knows what they're doing. They just forgot something silly. They really deserve the 4 on this question as opposed to a 3. Or they really deserve a 3 as opposed to a 2. Because they don't give you 0.5s. They're going to round it up or round it down. And they're more than likely to round it down than round it up. However, if that's why they're missing it, okay, that kind of gives you more information. Any okay with the method? And you're lucky because I know what the rubric's going to say. The rubric says the same thing for the last 10 years. Name or formula. That's the name. 1 samp prop Z int. And on Tuesday, it's going to be 2 samp prop Z int. Okay? On Tuesday, it's going to be 2 samp prop Z int. That's why I say if you miss the method, you just don't know how to count because it's either 1 sample or it's 2 samples. Good enough? And then we're going to add hypotheses testing in there. We're going to have 1 samp and 2 samp those. And then we got means, 1 samp, 2 samp. You'll kind of start seeing the methods kind of get up there fairly big. But right now it's easy. Conditions. You already know these conditions, but you got to list them. That's one of the C's. What if I forget to do the conditions and I do it at the end? They don't care. You got to get them on the paper. How many conditions are there? 3. And get all 3 of them on there. Get all 3 of them on there. Random, representative. Most of the time, it's going to be a simple random sample. And most of the time, SRS is good. They really like for you to say, we have a SRS of, right? They really like for you to somewhat get it in context. This kind of looks like you're just following the check boxes because you know it's supposed to happen, not necessarily that you really checked it. A lot of times I'll get a student to say SRS and they'll circle it in the problem. But you just have an answer sheet and your question's over here. So it's hard for you to go back and circle it in the problem. Follow what I'm saying on that? But somehow or another, we got to get that in there and it's going to be in the problem. It's going to be so obvious if this is not met. It's going to be obvious if it's not met. Large counts, you got to prove it. You got to prove it. I'll get a student to mess up every once in a while because they'll get lazy and because they'll say, oh, just like I did. I put N times P, and that's wrong, right? Because I don't have a P. All I got's a P hat. So make sure you put your hats. Make sure you label things correctly. Yes, they'll ding you if it's wrong, okay? I love for students to put approximately normal. I do. Again, that just tells me a little bit more that you know what you're doing rather than you're just checking the boxes. Large counts, check. You put large counts in check, you're getting dinged, no doubt, because you didn't really check it. You just know that you're supposed to. You got to show the numbers. You got to show the numbers that you checked it. Do I have to say it's approximately normal? Again, that just helps you. Large counts condition is met. Again, the more you can put there, you're good, but you don't want to write a novel. And then the last one is the 10%. The 10%. And again, the sample has to be less than 10% of the population. Don't say that backwards. Don't say it backwards. The sample has to be less than 10% of the population. You can say the population is 10 times the sample. Y'all okay with that mathematically, right? If this is 10%, then I can go on that side and say 10 times. So you can say it that way. Or my sample size, well, never mind. I don't want to just do it right. They're pretty lenient on these as long as you got something in there that's correct. I'm pretty lenient on these, provided I just don't think you check boxes and as long as you got the stuff on there, you're good. You don't have to write a novel, but you just got to make sure that I know that you actually check those things. Y'all okay with those 3 conditions? Okay, so method, conditions. You don't have to do these in order, but this is just the order that I do them in because I like to check the conditions first in case what? It's not met. If it's not met, I really can't go on. Okay, conditions. The next one I'm going to call is the calculations. And you don't have to show a whole lot here. You really don't have to show a lot here. You just got to do something. Label what P hat is. Tell me what P hat is. You do not have to tell me what the z-score is. You do not have to tell me what the z-score is. But if you know what it is, tell me. Because that gives you ammunition. That tells you, hey, I know what I'm doing. I just messed up somewhere. Again, I've seen students list all this stuff and get the interval wrong and still get an E. I won't do it, but AP will. Okay? N equals what I used to make students do. I used to, because I thought it was important that they really know what they're doing, is show P hat plus or minus Z square root P hat 1 minus P hat N. This really, this makes a whole lot of sense to me. And then right underneath that, I'm going to say 0.32 plus or minus 1.96 square root 0.32, forgot the 2, 0.68, 173. Where'd you get those numbers? I don't know, I made them all up. And then right below that, I'm going to have my interval. And what's cool, guys, is your calculator is going to give you the interval without having to do all this math. It's going to give you the interval without having to do all this math. It's going to be boom, 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 enter, poof. It gives you the interval. The math is not the issue with this problem. Never do I see a student miss this because of math. They miss it because they forgot to put something. This is beautiful to me. It's probably a little bit more than they require, right? Because they don't require the formula provided you did the method. But if you didn't do the method and you don't do this, you're getting dinged because we don't know really what you're doing. This tells me that I'm doing a one sample proportion Z interval because that's the formula for one sample proportion Z interval. Okay? Any questions on that? Anybody have a clue what the last C is? Oh, so here, this, again, I've changed this. I'm not going to make you show the formula. I'm not going to make you show the, well, at some point you got to tell me what p hat is. If you don't have a p hat in there somewhere, you're going to get dinged. You probably should tell me what n is, but you did that in the conditions. You did the p hat in the conditions, right? Like I said, you got to have it somewhere on that page. Somewhere. Somewhere. You don't have to tell me what Z is, but if you know what it is, you might as well put it. Doesn't take that long. And then, of course, you got to have the interval. You got to have the interval somewhere. Okay? And then your last one is your conclusion. And guys, you already know this conclusion because it's going to say construct and interpret a 95% confidence interval. So you interpret it. We are 95% confident that the true proportion of blankety blank, 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 blank lies in the interval of blankety blank, 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 blank. They'll accept this. We are 95% confident that the above interval, because you already put it right above it. Fair enough? So I don't have to really state the left and the right because I've already done it. What if I do? Okay, good. It's not wrong. They're really looking for the context, right? They're really looking for the context. 95% confident. They're looking for the true. They're looking for the word all. They're looking for the word population. Okay? Each one of those is its own E, P, or I. Not each one. The M's not its own E, P, or I. But it's worth 12 points. That's a 12-point question on your next test. That's a 12-point question. What's really the only way you're going to miss it is not put one of those things up there. You are not going to miss it because you get the interval wrong. I hate to say that, but I just really think you're going to have to work harder to miss it than to get it right because your calculator is going to do all the work. It's going to do it all. We're going to do one here in just a second. Who has a question? Who has a question? Some students, and after grading it this year, it's pretty nice. Questions up here, and they'll put a big old plus sign. They'll put a big old plus sign. And that helps me remind me that I need something in each one of these blocks. I need the method. I need the conditions. I need some type of work or calculations, and I need a conclusion. Do you have to do that? No. But that helps organize things and get your mind right. I go through and start counting 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 2. 1, 2, 3, 4, 5, 6, no conditions, minus 3, minus 4, whatever I put, whatever we do on the conditions. Your first couple conditions, I think I start doing 4 points, and then I start doing 3 points. And any questions about any of this stuff? Hopefully you can see why that most people do fairly well on this test, because I'm telling you what the question is, and I'm telling you how to get all the points. I mean, I'm just telling you. If a free response asks you to construct and interpret, make sure you construct and interpret. The thing that sometimes gets student is they forget to check the conditions because it won't say check the conditions, construct and interpret, but you got to check the conditions in order to construct. You are expected to do the entire, again, 4-step process, 3-step, whatever step you want to call it. I don't care. You're expected to do everything. You're expected to do everything. Y'all ready to see one? I think this was an AP question one year. I think that's where I got it. I think it was, I can't change it up a whole lot. A recent poll, 738 randomly selected cell phone users found that 170 of the respondents, I thought everybody was in here, but I lied. While walking into something or someone while talking on their cell phone. Construct and interpret. There's that famous word, construct and interpret. A 95% confidence interval for the proportion of all cell phone users who would admit to talking or walking into someone. Y'all have some room to work on that? SRS of 738 cell phone users. And I'll put a check mark there, but do you have to? No. Can I put SRS 738? You're starting to get a little ambiguous. SRS check, I'm going to get you on that. I think you're just following along. Okay? Just a little bit of something. Use a little bit of it. You want full points. Don't give me any doubt to take a point away. Don't give me any reason to take a point away. I don't know if 738 is less than 10% of all, but I'm going to want to see that because I'm referring to that population of all cell phone users. But my bet is it is. My bet is there's probably over 7,000 of them. We probably got over 7,000, maybe in this school. Probably not. There's only 3,000 students, but. N times P. Now, again, here's where some students might mess up. They might tell me that 170 is N. Don't mess up and do something silly. N, that's your sample size. 738 times P hat. Now, again, do I need to put N times P hat? Somewhere you got to tell me what P hat is. Somewhere you got to tell me what N is. I do it in my calculations. Can I do N times P hat is greater than 10? No, because I don't know what N is and I don't know what P is and I don't know that you checked it. 738 times 170 out of 738, which actually equals 170, ironically. Sometimes some books would say, rather than greater than 10, they would say the number, listen to what I'm going to say, the number of successes and the number of failures has to be greater than 10, which is the same thing as N times P, because N times P is the number of successes, and N times 1 minus P is the number of failures. Greater than 10. And so that has to leave what, 600, 500, 568? I don't know if that's right or not. And then, guys, what I would really like to see is, here's what they would really like to see. It would probably come up in a multiple choice at some point. So the sampling distribution is approximately normal. That's really what they would like to see. I'm okay with just approx normal. I'm okay with large counts is met. I'm okay with really nothing. But the more you put and the more you sound intelligent, the better chance you're going to get is more points. Y'all okay with all I'm saying on that? 1, 2, oh, 3. I got all 3 conditions. I got all 3 conditions. I'm probably giving you 4 points on that somehow, some way, some form. I used to count approximately normal as a point. I'll have to go back and look at the rubrics. Sometimes they wanted that. Sometimes they had to have that. Because that's what you're checking for, so that you can use a z-score. And you have to use a z-score to say it's approximately normal. But they've come a little bit more lenient on that lately. You can put 1 samp prop z int, because you're lucky, because that's the only choices you got right now. And so that's the method. But if you don't want the method and you would rather put the formula, put the formula. P hat plus or minus z. You can put the asterisk there or not put the asterisk there. If you do, great. If you don't, we're not going to hurt you. And then we'll put square root and p hat, 1 minus p hat over n. What happens if I don't do hats? Yep, you're going to get dinged because you're lying. They're not p's, they're hats. So if you're worried about maybe messing up on that, don't put something wrong. Don't put something wrong. You're better off leaving it off than putting something wrong, because putting something wrong is wrong. Leaving it off might just be forgetful, but it's not wrong. If it's something you have to have, you're going to get dinged. You'll kind of hear what all I'm saying on that, right? Like I said, you guys have been with me long enough. You kind of followed some rubrics. You kind of follow what's going to happen here. I probably need a p hat on there somewhere. Did anybody calculate what that p hat is? .23 is my guess. You got it? Oh, backwards. Okay, so 0.23 plus or minus 95, 1.96. Square root 0.23, 0.77, 738. Again, some students might mess up there because they'll put 170 as opposed to 738. Yes, sir. Yes. Yep. Any questions so far about this stuff? Let me show you in the calculator how we're going to get the interval now, because I'm for sure not punching this stuff up to get this. Because you're going to take forever and you're going to mess up. You're going to mess up. Don't. Just let your calculator do the work, because it does it all for you. It does it all for you. Here, let me show you. Provided you do it right. I told you one of these buttons we're going to wear out. We're going to wear it out this semester. This one that says stat. We're going to wear that bad boy out this semester for sure. Now, I don't need to edit because I don't have any data. So I sure don't need to sort it. I sure don't need to sort it. And I sure don't need to clear it. And I don't need to set up a letter. What if I have stuff in there? They don't care. I'm not using it. Calculate. I don't want to calculate anything, although it does make sense that we're going to calculate things. But we're not, because confidence interval is not on here, because TI is an idiot and they archaic. They're going to go over to tests. And why are they going to go to tests? I don't know, because that's where they put the stupid intervals. Test, 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 test. Z interval. Don't. It is a Z interval, but look what else we have. Let me, what if I forget? What if I accidentally do Z interval? Look what it asks for. I don't have that. Well, no duh, because you're doing the wrong thing. Okay? So, quit, get out of that, get out of that. Okay, stat, test. So don't do Z interval. Go down a little bit further, and here's a 1 prop Z int. What's that? The method. Oh, I should write that. Oh, that would be a good idea. I should probably highlight that A, if that's what I want. And now it's pretty easy. X, number of successes, 170. Okay, listen to me carefully, guys. This is one time I'm going to say it, and it happens once or twice. That cannot be a decimal. That cannot be a decimal. What if it is? Change it to a number, round it. Round it. It's not going to be that big of a difference in the interval. Okay, but if that's a decimal, it's going to give you an error. It will. Because it's the same program they had when I bought my first TI in 1984. Because they haven't changed it since, except they put center in there. 170 out of 738. Is that right? Confidence level, don't put 95. 0.95. Calculate, and there's your interval. Guess what else they gave you? P-hat. Guess what else they gave you? N. Oh, I should probably put that on my paper. Where? Don't care. Get it on there. Get it on there. Do I need to show step by step? No, they want the answer. They want the interval. And I told you that you can get the interval wrong. I told you the one time I had a student that calculator died. He did his entire test without a calculator and got a 5. The entire test, because he knew what to do and knew how to do it. He just couldn't do it. I would use my calculator to find these values, but I don't have time to do this math mentally. And I have no idea what the square root of this number is. And I mean, I didn't grade his paper, but he said my calculator died. Any questions about that? Now, don't forget your last C, though. Don't forget your last C, because that's 4 more points. We are 95% confident that the true proportion of cell phone users who ran into something or someone while talking on the phone is between that calculated interval. And yes, I could easily abbreviate that to 0.2 to 0.26. You don't have to write 0.199997. If you want to write 0.2, you can. If you want to write 0.20, you can. If you want to write 0.199, you can. If you want to write, they don't care. They're not going to ding you for rounding like all the other classes. Don't round it to 0. We are 95% confident it's between 0 and 0. Don't do that. Give me a decimal. Who has a question on that? I'm not completely done yet. Bear with me. Bear with me. Yeah, absolutely. Yeah. Okay. Click. Method. One sample prop Z N, 95% confidence interval. P, they're defining what the population is. Somewhere they're going to want you to define the population. You guys do it, or we do it as our group in our conclusion. We do it in our conclusion, but they're going to want to know what the population of interest is. Okay? Random, 10%, large counts. Notice how they typically do it with check marks. Okay? Not only did you do it, list it, you checked it. Calculations. I didn't put any calculations on there, right? And then your conclusion. Calculator, I showed you. It's under tests. Don't do Z interval. You'll know it when I don't know what sigma is. Nobody does. I don't know what it is because that's population. I don't have population stuff. So prop Z int. Okay. Now, here we go. Last thing for today. And I apologize for taking your whole time, but I think it's that important because I won't have to take this much time next time, especially on Tuesday. Like Tuesday, we'll blow through that. It's just a couple different things. Planning a study, we may want to choose a certain sample size to ensure my margin of error is a certain value. Okay? we might want to be given a certain margin of error. Well, we know two things about that margin of error. I can change the level or I can change my sample size. And they're going to tell me the level, so I can't change that. But I can change my sample size. Okay? So here's what you know about the margin of error. It's everything after the plus and minus. So it includes the z-score, it includes p hat, 1 minus p hat, and it includes n. And what do we have? They're going to tell me what? They're going to tell me what they want that margin of error to be. And we're going to have to find n. And they're going to tell me what the level is. Now we got an issue. Because this is p hat. How do I get p hat? From the sample of the size we don't know yet. Fair enough with that issue? I'm going to try to take a p hat from a sample of the sample I don't know what the size is yet. So watch. What if I used 0.1? Well, 0.1 times 0.9 is 0.09 because it's p times 1 minus p. Y'all follow me? Mathematics. P times 1 minus p is 1. So if I did 0.2 times 0.8, that's 0.16. What's my margin of error? Or what? I shouldn't say that. I'm sorry. What's my standard deviation doing? Getting bigger, right? 0.21, 0.24, 0.25. What's going to happen at the next one? It's going to start going back down. Y'all okay? So here's what they're going to say. If we don't know what p hat is, which we don't because we haven't taken a sample size yet, we're going to use 0.5 because that is the worst case scenario. I can't make it any wider than 0.5, 0.5. I can't. So I'm going to ensure my sample size gets there by using 0.5, 0.5. By using 0.5 for p hat, sorry, my mathematics won't do a p hat, okay? My typing doesn't. We're using the largest possible value for p hat 1 minus p hat in our calculations. It is our worst case scenario. There's no way it can be wider than that. Okay? Let me go quickly. I know bell's going to ring. A company has received complaints about its customer service. Managers intend to hire a consultant to carry out the customers. Before contacting the consultant, the company president wants to know the idea of a sample size that will be required to pay for. One of the values of interest is the proportion of P. I want it to be within 3 percentage points. So we have 0.03. It's a 95% confidence interval. So that's 1.96. Square root, this is going to be 0.5, this is going to be 0.5, and you guys have got to use Algebra 2 to figure out what that n is. Divide both sides by 1.96, square both sides, whatever you guys got to do to solve that for n. But you should have had Algebra 2 for that to at least solve that for n. If you can't solve that for n, let me know. And I got a calculator program that did it. Okay, so Tuesday, I don't see you guys until, I'm sorry, Thursday, I don't see you guys until Tuesday. Your assignment is already listed, okay? Go through that, focus. Review papers, do you want those now or you want them later? Some of you want them now. Let me hit stop on this.